Greetings, my pooligans. I'm Chewy from the Mana Pool. A short while ago, I grabbed Cluze and we did a nice long stream about the new James Webb Space Telescope because we wanted more people to appreciate just what a big deal it was. The stream proved to be pretty popular, so I decided to use the video version of it to launch the new YouTube channel, where you're currently watching this. Feel free to subscribe while you're here. Of course, I didn't think dropping a 2.5-hour video was really a way to get eyes on the new channel. It's a bit much, you know? So, I decided to try to break the full stream into pieces that made sense. This is the first piece. In this video, Cluze and I will do our introductions and explain the purpose of the full stream. From there, Cluze will launch full-on into Professor mode, and he'll give us a brief history of some of the huge paradigm shifts in the history of astronomy, all the way up to the Hubble. Why? Because to understand why the JWST is such a big deal, you have to understand just how far we've come up until this point. The timeline, by the way, of these massive discoveries that completely changed our understanding of the universe might just surprise you. So, hey, I hope you enjoy the first video on my new YouTube channel. Now, take a deep breath, because this is the deep end. Dum 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 jam.
Yeah, plosives.
Sibilance.
Sibilance.
Last night, his sky was not overcast, which is why we didn't do any pre-show stuff last night, because he was using a real telescope like a space nerd.
Yeah, I totally was. I was out in my backyard observing the actual nighttime sky. I will apologize if I keep clearing my throat. I made a terrible mistake, or was it a perfect mistake? I had some ice cream just before I came on stream, and so now I'm all phlegmy. All right.
You ready to go, Cluze?
Yep.
Get your beginning the stream face on. That works, yeah. Ow, jam! Hello, everyone, and welcome to this very special stream/YouTube event. I am Chewy, as always, and I am joined by my former co-host and still very good buddy and spaceman, I think is the technical term. It's Cluze.
Yeah, I'll take Spaceman. I'll totally take Spaceman. And yes, as someone in the chat noticed, I am wearing one of my space bow ties tonight, so it does have some constellations on it. Pulled that out of my bow tie collection. Just perfect for tonight is the way I will say that.
I put on my It's Round shirt because of what we're talking about. So, Cluze and I were absolutely blown away, just flabbergasted, other assorted words that describe this feeling here. I compared it to a religious experience, I'm not gonna lie. When the new images from the James Webb Space Telescope were revealed, and I noticed a lot of people like, oh, it's pretty, and that's all they said. And I was like, I don't think you understand what we're looking at here. And late one night, just a few nights ago, I had this idea. Oh my God, I should get Cluze, and we should explain to people in, plain English what's so insane about this. Because the fact that the James Webb Space Telescope exists at all and functions is just a triumph of human ingenuity. And then what we're getting for so
we are agog and occasionally at a loss for words. Absolutely. Yeah.
Yeah. So we want to explain what is the James Webb Space Telescope, because all of us know the Hubble. Like, the Hubble's been there since, what, 1990?
1990, yeah.
Yeah. And everyone knows that. A lot of you, well, some of you listening might not even have known life without the Hubble. Which, wow. but the new space telescope isn't just another Hubble. It's a whole other uh, ball of wax, let's say.
Yeah, that's a really important point that we do need to stress. A lot of people think of the JWST as being Hubble 2, and that's not quite right. It is the successor to Hubble, but it's not the replacement to Hubble. So it's not like we're turning off Hubble. It's got plenty of usefulness in it, and
Yeah.
I'll explain why as we go.
Yeah, to go with
Bef-
an analogy that I had on Twitter when these images were revealed, just because you got a Super Nintendo doesn't mean you have to throw away your Nintendo Entertainment System and all its games.
that's right.
Like, those
That's
games
right.
are still fun, they're still really good, but now there's this other thing that can do more.
Yeah,
Yeah.
yeah. It's not a bad analogy. It definitely isn't. Before we get underway, though, I do want to make a couple of quick comments, and then we want to give you some perspective and some background to really put things in context before we start to dissect some of these images. The first one is, yes, I am technically a spaceman. I do teach astronomy and physics at Central Michigan University. So fire up chips if there are any Chippewa in the stream or watching this later on the YouTubes. But I should stress, I'm here in a personal capacity. I'm not really here as a representative of my university, but I did want to acknowledge that. Also, I am an astronomer by trade, but that's that doesn't mean I know everything about astronomy, right? I mean, there are many flavors of engineer. If you're talking to one engineer, they don't necessarily know everything about all areas of engineering. So there are going to be some things that we talk about tonight that aren't really my specific area of expertise. I don't really do a lot of extragalactic astronomy. Most of what I tend to work on tends to be within our own galaxy, and we'll try and put that into some context later. I also don't really do infrared all that much. I'm mainly invisible, mostly because that's what you get from the ground.
Cluze is mainly invisible, see?
I do dabble in these things, and I do have some knowledge of these things. So I'm going to try my best to take my background in teaching, because I do a lot of teaching, and try and put some of this into perspective for folks who might not have spent, I don't know, the last 20 years of their life involved in astronomy like myself. So that's our goal tonight, is to try and give you a better appreciation for why the James Webb Space Telescope, the JWST, why it's so special, why it's so interesting, why these results are so mind-blowing, and I'm going to argue why we are at a true milestone or a turning point for astronomy as we know it. So I want to start by going way back.
Okay,
Like
wait, before you
way-
get started, let me issue my disclaimers. I
sure.
have a bachelor's degree in physics and astronomy, so I am not just a layman enthusiast. I also aced astrophysics when I took it, so I also aced quantum, but we won't get into that. I did not ace any of the other high level physics classes. And I have been a fan of astronomy since I was very little. Like my second, I was telling Clues earlier, my second love was space. My first love was dinosaurs, obviously. And my second
His third love was space dinosaurs.
uh, if we find any of those, they'll shoot to the top of the list. And then Greek mythology fell in there somewhere, but I don't remember if it was before. I think it was after dinosaurs and astronomy. So, yeah. And I've kept up mostly over the years with how new technology works and whatnot. So, yeah. I have a good idea of what we're talking about. Clues has a great idea of what we're talking about.
And hopefully by the end of this stream, you all will have a better idea of what we're talking about.
Exactly.
At least that's our hope.
So, going way back.
So to start things off, I want to go way back. And I'm just going to put a little bit of perspective on how we got to where we are. So first thing you've got to realize is that we don't know when human beings first really started to gaze at the nighttime sky and ponder their place in the universe. But we do know that human writing goes back to about 3400 BCE. So we've got about 5,000 years of written history for human beings. And during the vast majority of that time, the only things we knew about were what we could see with the naked eye. So you had the sun, you had the moon, and you had the 6 naked eye visible planets. You had Mercury, Venus, Earth, Mars, Jupiter, and Saturn. And that is it. Those are all that you had. And even for much of that time, we didn't necessarily recognize that Earth was similar to those other objects. We just knew that they were different and they were special.
Yeah. Well, I mean, back
We
then they were just stars that moved funny.
Yeah, in fact, the word planet it comes from a word meaning wanderer because they
Yep.
moved relative to the background stars, and that's what made them interesting to ancient peoples. So if you fast forward, just a tiny bit from the beginnings of humankind, and you go to the late 1500s, the telescope was invented. It wasn't invented by Galileo. I want to dissuade you of that, but it was used by Galileo rather quickly after he learned of its existence and he built one of his own. In the early 1600s, Galileo took that telescope that he built and he made several discoveries. Among them was discovering moons around Jupiter. So he can actually see the disk of Jupiter itself and see some moons that went around it. So this was the first time in human history that anyone had ever seen an object orbit not the Earth, because at that time it was still widely believed that the sun and the moon and all the planets and all the stars all orbited Earth, which wasn't at all true, but here was our first evidence of that. So for like the vast majority of human history, the Earth was the center of everything. And here's our first cracks in that idea. His other observations, one of them was observing the phases of Venus, which is what actually proved that Venus orbits the sun and not the Earth. So that, again, was a paradigm shift. It really came to Galileo. It's why the moons of Jupiter are known as the Galilean moons. It's why this was the Galilean revolution in understanding of astronomy. So that was a shift in our understanding of our place in the universe. We then fast forward not nearly as long. We go like a little over 100 years later, and in the late 1700s, William Herschel discovers another planet using a telescope. Now, at the time, he was hunting for comets. He was looking for fuzzy things in the sky, and he found something that might have been a little better than a fuzzy thing in the sky, and that was what came to be the planet Uranus. So that was amazing. We went from having 6 planets, including the Earth, for most of human history, to suddenly having 7, now that we had this new technological advancement, the telescope. Then, less than 100 years after that, we discovered another planet, and that was Neptune. Now, Neptune is interesting because we actually took the observations we had from telescopes, from the technology that we had, and we predicted mathematically that Neptune must exist before it was actually discovered. Uranus was discovered by accident, but Neptune was discovered on purpose. We knew where to look. Now, I'm going to...
fascinating.
It is. It absolutely is. We could spend an hour just talking about, what I just talked about in the past 3 minutes. But we got a lot more to get to. I'm going to skip over anything about Pluto. And I know that there are Pluto fans out there, and that's totally fine. But tonight is not the time to talk about Pluto. We've got, I'm going to say, bigger fish to fry. We've got other fish to fry. That's what we'll say.
More delicious fish.
But once we had these telescopes, among other discoveries that were going on, is we were finding things in the sky that weren't stars and weren't planets. They were fuzzy things. They were patches in the sky, things that were called nebulae because they looked like little clouds. We didn't really know what they were. Well, we gave them names, but we didn't know what they were. And at least one of those names was a terrible name, and we'll get to it later on. But among those things that we found were these things called the spiral nebulae. And they looked exactly like they sounded. They looked like little spirals, little whirlpools in the sky. We didn't know what those were. And it wasn't until the 1920s, so 100 years ago, that we started to get an understanding of what those things were. There was a big debate about this. In the early 1920s, there was a debate between Harlow Shapley and Herbert Curtis called the Great Debate in Astronomy. It's a great thing to look up if you'd like to hear some interesting stories about astronomers. We didn't know if the spiral nebulae were part of the Milky Way galaxy, that band of stars that we see in the sky that is our own galaxy that we're seeing from the inside. Were those spiral nebulae part of our galaxy, or were they galaxies in their own right? Were they a giant object really far away? And we just didn't know. So just think about that. 100 years ago, we thought that the only thing in the entire universe was the Milky Way galaxy. That was it. And during the late 1920s, a little guy by the name of...
To add a little historical context to that, the first flight by the Wright brothers was in 1900 something. 2, I want to say, 3, something like that. So at that time, when the first time humans flew under their own power, we still believed that.
So a little guy by the name of, you probably never heard of him, a guy named Edwin Hubble in the late 1920s made some observations of these spiral nebulae, and he measured the distance to one of them, the spiral nebulae in the constellation of Andromeda, what we now know is the Andromeda Galaxy. He measured the distance to that, and he showed that it was much, much further away than the size of our own galaxy, proving that our galaxy was not alone. There were many other galaxies. How many other galaxies? Well, we didn't know at the time exactly how many, but we could go, hey, the spiral nebulae, those are full other galaxies. So that was, again, a sudden paradigm shift in our understanding of our place in the universe. So Hubble continued his work and measured distances to these spiral nebulae and measured, among other things, the motion of these spiral nebulae. And he found this really weird thing that's going to be important to us in our discussions in a few minutes. And that is that the further away these things were, the further away these galaxies were, the faster they were moving away from us. And because of that, the light from those galaxies was redshifted. It's slightly redder than you would expect it to be. And the faster they're moving away from us, the more red it is than you would expect it to be. So from that moment on, we also went from our belief of a static universe that was essentially unchanging in time to a dynamic universe. It's not only a much bigger place, but it's a bigger place that's in motion. And stuff that's really far away is moving away from us really fast. And so if we want to observe that stuff, we're going to have to look redder and redder and redder the further away we look. So that's going to be something that will be important to us a little bit later on. This idea that as things are moving away from you, they're redder, this is a thing called Doppler shift. So if you want to dig out your introductory physics textbooks and look up more on Doppler shift. So not long after that, relatively speaking, so again, this is late 1920s into the 1930s, the astronomers and scientists of the time were already starting to think about, hey, wouldn't it be great if we could take a telescope and we could put it in space? Because, not long after that in the 1940s and moving on from there, we had, a few wars we're not going to talk about, including a Cold War and a space race. And we put people in space and we put satellites in space. And there was finally this idea of, hey, what if we put a telescope in space? So there were plans to put a telescope in space as far back as something like 1946. Was, I think, the earliest that I could find of serious proposals by scientists to put a telescope in space. So we were thinking about it basically from the get-go. Like as soon as someone said, hey, I can take a rocket and I can put some stuff up there, we're like, hey, how about a telescope? So we were thinking of that very, very early. I'm going to skip over a bunch of stuff now. We're not going to go quite 100 years in the future, but we're going to skip over a bunch of stuff, and we're going to go to the early 1990s. And again, this is something that a lot of people who are watching this or are hearing this, that you may not have ever known a world without the Hubble Space Telescope. But we built one of those space observatories. We built a lot of different kind of space detecting instruments, but it wasn't until the launch of the Hubble Space Telescope in 1990 that we had a true, what if we just took a regular telescope and put it in space? And here it is, the beautiful Hubble Space Telescope. An absolutely amazing, amazing feat of engineering. And the Hubble Space Telescope really was designed as one of NASA's quote-unquote great observatories. It was like a capstone project, this incredibly capable instrument put in space. And it was definitely meant to be essentially just a regular telescope in space. It primarily looks at the visible wavelengths. And what I mean by that is the same kind of light your eye sees. So just like you would go to an observatory on Earth and look through the eyepiece, this is like we just took one of those telescopes and we put it up in space, okay? The Hubble Space Telescope, it can see a little bit into the infrared and a little bit into the ultraviolet, but it was primarily a visible light instrument. And you want to do that because the atmosphere is horrible for astronomy. Like the number one problem we have with doing astronomy on Earth is that there's air we can breathe, right? If we didn't have the atmosphere,
It's a bummer.
we would have a much easier time with astronomy very briefly, and then we'd all die. So it's a good thing that we have an atmosphere, but it does make the images blurrier, and it does block out some kinds of light. About the only light that really makes it through the atmosphere very well is visible light. That's why our eyes see those kinds of light. But if we want light that's redder than that or bluer than that, it's not great. We need to actually take a telescope up to space. So that was the idea behind the Hubble Space Telescope. The Hubble Space Telescope is not that big of an instrument overall. The Hubble Space Telescope, we're going to show a comparison of it to the JWST here in just a couple of minutes. But its mirror isn't all that big, quite frankly. But it was the biggest instrument we could fit inside of the cargo bay on the space shuttle, because that's what we launched it with. When Hubble was first launched, there were some problems with its optics. There was an error in how they were constructed, so the images were a little blurrier than we expected. Now, at the time, there was a lot of, hay made by politicians that, we had this broken, billion-dollar telescope that's terrible, yada, yada, yada. What you don't understand is that even when Hubble was broken, the images from Hubble were so much better than anything we had on Earth that even if it was never fixed, it still would have been the greatest instrument we had ever constructed.
Yeah.
But it was fixed. We knew what was wrong, and within, we looked this up just before the show, I think within 4 years, I think it was 3 or 4 years, we had parts
It was
to
launched
replace
in 1990, and like April, I think you said, of 1990?
Yeah, I think it was April.
And in January of 94 was when they officially declared that the service to fix it was 100% finished. So
it was like 3.5 years.
Roughly,
until we fixed it. But one of the neat things about Hubble, even though it was very expensive and very difficult to build and to put into orbit, is that we could service it, because it is in low Earth orbit. It's right next to the Earth's atmosphere. Yep. So at least as long as we had the space shuttle, we could go up and we could fix it. We could add capabilities, update cameras, that sort of a thing. And we did that for a long time until we no longer had the space shuttle. And now the Hubble is not serviceable, but it is still going strong.
Yep.
Okay, so the Hubble is now over 30 years old.
I can't remember when the last service mission was, but I don't even remember what it did, but I remember it was like we had a new instrument. I don't think it installed a new instrument, but I think it adjusted something.
Yeah, and I want to say that was the late 20-aughts.
I think you're right.
Approximately. I can't remember offhand.
Well, Sorry what? I have the internet right here. Why don't I just look it up?
You do. So that's Hubble, the Hubble that we know and the Hubble that we love, and it gave us unparalleled access to the universe. One of the things that the Hubble did for us, and I meant to put this picture in for our little slideshow, but I didn't. One of the things that the Hubble did for us.
Servicing mission 4 was in May 2009. It installed a replacement data handling unit, repaired a few systems, installed improved batteries, and replaced other components, including all 6 gyroscopes. Oh, wow. Oh, nice. It did install 2 new observation instruments, the Wide Field Camera 3 and the Cosmic Origin Spectrograph. Okay, I remember now. And the Soft Capture and Rendezvous system. Ooh.
So one of the things that they did with the Hubble, they stared at the blankest patch of sky they could find. So they literally took the tiniest, blankest piece of sky they could find, and they stared at it, and they made a thing called the Hubble Deep Field. Later, they revisited it to get more data, and they made the Hubble Ultra Deep Field, and then later they made the Hubble Extreme Deep Field. But in all of those cases, they revealed another truth about the universe, and that is that even the blankest piece of sky we can find, if you stare at it long enough, with an instrument sensitive enough, it's awash with galaxies. Like there's just galaxies everywhere you look. So again, the Hubble gave us this new insight into our place in the universe and what the universe is like.
That's a question I wanted to ask.
Yeah.
Now, we all know the Hubble Deep Field. They pointed it at a piece of sky where there was nothing to see what they could see. Was that a revelation to see all of that there, or did science expect that?
Yeah, I'm going to go a little bit of both. We were pretty
That's what I
sure
was
you would
thinking.
see galaxies. I don't know because this did happen when I was a little younger. I don't know that we expected quite as many as you see in the Hubble Deep Field, but we expected some galaxies.
Yeah.
Absolutely, space. Space is simultaneously empty and never empty, if that kind of makes sense. Space is stupendously big, but in any direction you look, there's probably a galaxy along that line of sight.
Yeah.
Um,
So there you have it. It's absolutely fascinating how far we've come in how short a time, isn't it? Feel free to hit the like button or leave a comment to appease the angry algorithm gods and help get this new channel off the ground. And since you're already here, you might want to go ahead and subscribe to the channel, because in the next video, Cluze and I will discuss the JWST itself, why it looks like a big Lego creation, what makes it different from the Hubble, and why it's so insanely far away. But that'll do it for our first dip here in the deep end. I've been Chewy, waving and drowning, and I want to thank all you Pooligans for joining me. The second part will be up very shortly. See you then.